We can also use KSPs to predict whether or not a reaction will occur. And what we're talking about here is whether or not precipitation will occur given certain concentrations of ions. Now we've got our Ksp expression here, and we can also, just in place of that, put a Q. And that would mean that we're not at equilibrium if we're talking about Q. And what we're saying here is if Q is less than Ksp, precipitation will not occur. If Q is greater than Ksp, precipitation will occur. I'd like to explain this in terms of a K expression. Now what I want you to do is pretend that we've not got Ksp, but we've just got K. And if we've got K for this process, which is just the dissolving of MgOH2 solid, then what we've got is the reactants on top here as being the ions and the solid being down on the bottom. Now here's what I want you to see. If Q is greater than K, what's going to happen is the reaction will move towards the reactant side. The reason for that is because Q will want to get smaller, and it can get smaller, get closer to K, by making this larger. Therefore the reaction will move towards the precipitate side, or the solid side. So that's why over here I was saying that if Q is greater than Ksp, precipitation will occur. Likewise, if Q is less than K here, then what's going to happen is the reaction will move to the product side. Now the product side are ions. So what we're talking about is solid dissolving or moving towards this side. So if Q is less than K, the reaction will move to the side that has the ions on it. And that's why I was saying over here, if Q is greater than Ksp, if Q is less than Ksp, then precipitation will not occur.